Class, and welcome to another one of Mr. Leader's fantastic lectures on volumes of prisms and cylinders. Okay, this that we are showing right here is called a prism, and a prism is a 3D figure that has two bases that are parallel to each other and are congruent. So this one here is called a rectangular prism because the bases are rectangles. It's also called a right prism because all of the sides are at right angles to the bases. So this is a right prism because those are at right angles to the bases, like that. Whoops. If this, a prism that is not a right prism is called an oblique prism, and I'll talk about that later. Okay, so now we're going to be talking about the volumes of these prisms, and so if you probably know how to find the volume of a prism already. If this is 10 and this is 3 and this is 5 over here, you probably already know that the volume of this is 10 times 5 times 3, and you just multiply and you get 50 times 3, which is 150. And if these are inches, then the volume of this figure is 150 cubic inches, which I write like that. Okay, now what exactly does that mean? That means that I could take 150 little cubes, which are 1 by 1 by 1, 1 by 1 by 1, and put them into this box, and they would fit perfectly inside that box. Okay. Another way to find the volume of any prism is merely to calculate it by using this formula. Volume equals, whereas this formula is, you might think of it as length times width times height, right? But another way to calculate the volume of any prism, including ones that look like this, is by multiplying the B, big B times H, where big B does not mean the length of something, but it means the area of the base. Okay, so in this case, the area of the base is this thing down here. So if I multiply that base, the area of that base times its height, the area of the base is 50, right? And 50 times 3 equals 150. Got it? Good. Okay. So now we're going to move on to a little more complicated figure, like how about a regular hexagon? Okay. So here I have this is called a hexagonal based prism. And even though you can see that it's not resting on its base, it is still a prism because it has two parallel bases that appear to be congruent to each other. I'm going to tell you that they are congruent to each other. And besides that, I'm going to also say that this is this prism is regular, meaning that the base is a regular hexagon. So say, for instance, that this side over here is 6, and the length of this prism, or the height in this, and the height is let's say it's 10. Okay. Now this is a pretty complicated problem because first what you have to do is find the area of this regular hexagon. So what I'm going to do is draw in one of these 6 equilateral triangles, right? If I had a if I draw them all in, let's see if I could do that. If I draw in all of these equilateral triangles, you can see I have 6 of them in a regular hexagon. I'm trying to have 6 of them. And so we learned, or I tell you the formula, rather than find the height of each one of these, which is a pain in the neck, okay? I told you you can find the area of a regular hexagon by going of an equilateral triangle by going side squared root of 3 over 4. That's for the area equilateral triangle. And I have 6 of these. All right? So I'm going to take side, and side is also 6. So I have 36, because that's 6 squared, root of 3 divided by 4 times 6. And I didn't mean to cancel that out. That's just my pen making mistakes. And then I can cancel out a 4 into 36 9 times. So you get 9 times 6 on the square root of 3. So the area of the base is going to be 9 times 6. This goes away with the 4, right? 9 times 6, which is 54 square root of 3. That's the area of the base. And now I need to multiply to find the total volume of the figure. I multiply the area of the base, which is this area, times its height, which in this case it's really the length, since it's resting on this bottom side down here. So base times height would give you 54 root of 3 times 10, which is 540 square root 3. Okay? And if these are, let's say it's centimeters this time. Okay? And so that's going to be in centimeters cubed. Okay? So that means that I could fit 540 little centimeter cubes inside of this box. Whether they'd fit exactly in, that's a different story. Okay? So that's a little different type of prism. We also could have a prism that looks like where the bases look like a trapezoid. I found all this good stuff in various places on the internet. So here's one that I found, and you can see that that is a trapezoidal, that's called a trapezoidal based right prism, because all the sides are at perpendicular to the bases. Okay? And it has 2 congruent sides. So again, all you have to do is to find the volume, which we're trying to find. I would take the volume is equal to the area of the base times the height. So first we have to find the area of the base, which is this thing down here, or the top. And I can see that this, if you remember the formula for the area of a trapezoid, it's base 1, which we'll call 4, okay? And base 2 is 10 up there, times the height. Now the height is not this height here, that's the height of the prism. The height of the trapezoid is 2. Okay? Base 1 plus base 2 times the height divided by 2. Right? That would give the area of one of these bases. Now I'm going to multiply that times the height. Okay? And what's nice here, this goes away here. Okay? And I get 4 plus 10 times 7, which is 14 times 7, which is 28, 98. And that would be centimeters cubed. Yay! Okay. So the next thing we're going to do, we're going to go backwards a little bit. So these are the more trickier problems. More trickier? That doesn't sound right. But I'm going to find a different prism over here. This is another trapezoidal based prism. Okay? And I'm going to tell you in this case that this side is 6 and this is 8. Where's 8? No, not 8. This is 10 going across here. And that, what else do we know? And this height in this case is going to be 12, or it's the height of the prism, because these are the parallel bases, this base and this base back here. Okay, so this one is sitting differently than the other one. And then what I want you to find in this case is the height. So here we have to use a little bit of algebra. Oh, and I'm going to tell you that the volume of this thing, is 384. And they say find H. Find H. Okay. And all you have to do is go, there's h, I found it. No, that's not really what you do. Okay? What you do is you use the formula for the area of a trapezoid. So I'm going to go 6 plus 10 times the height, which is what I'm trying to find, times 2, that's the area of the base, times the height of the prism, which is 12, and I want that to be 684. Okay? All right, so to continue, I'm finding the height of this prism, the height of the base of this trapezoidal prism, whose volume is 684. And we always try to cancel things out, so a 2 goes into 12 6 times. And so over on this side, I get 6 plus 10, which is 16 times 6. What's 16 times 6? I believe that is 96 times h equals 684. And then I divide both sides by 96 by 96, and I get that h equals 684 divided by 96. I thought this came out even. Oh, I made a mistake. This I wanted to be 384, not 684. Sorry, 384. And this I want to be 384. Sorry. Okay. So this is 384. 384, and 96 into 384 is 4. So now we found the height of that trapezoidal prism, the height of the base of the trapezoidal prism. Okay? All right. Next thing we have is cylinders. Okay? And a cylinder, you probably already know. Ooh, that's one big cylinder. Let's see if I could make that smaller. First I have to get rid of this thing somehow. Okay. No. I don't want to move it. I want to squish it. Come on. There we go. That's better. Okay. So now I have a cylinder, and this is called a right cylinder. This one here is called an oblique cylinder, which means it's pushed over on its side. But it turns out the formula for both of them is exactly the same, and the area for finding this, the formula for finding the volume is exactly the same. It's still the volume is equal to the area of the base times the height. Okay, so in this case, for instance, say I know that the radius here is equal to 3, okay, and the height of this prism, or cylinder, sorry, is 8. Then I know that the volume of this is equal to the area of the base, which is pi r squared. So we're going to go pi times 3 squared times 8, which is 9 times 8, which last time I checked was 72 pi. And if that's in inches, let's call it inches cubed. Now we can go backwards too, okay? And they like to trick you with these ones. So say I have an oblique cylinder that looks like this, and this is 8. And so if I take this cylinder and kind of push it over on the side, if it was the same height and same radius, the volume would still be the same. It'd just be kind of pushed over. Okay? So say in this particular oblique cylinder, I know that the volume of that one is equal to 128 pi centimeters cubed. And they asked me to find r, find the radius. Okay? So what I'm going to do is I know the formula for this is going to be pi r squared times h. And in this case, don't use the 10. H is the height perpendicular to the base. So that's 8, not 10. Okay? And That's where they try to trick you. Okay, 128 pi. And then what's nice here is the pi's, you could divide away a pi from each side, and then I get r squared equals 128 divided by 8. What is 128 divided by 8? 4, 2, 1, 8 goes into there, 48, 16. Oh, look how convenient. So r has got to be equal to the square root of 16. It's actually plus or minus, but we can't have a negative radius, and so it's going to be equal to the square root of 16, which is 4. Done. Okay? Just a couple more things. We also have things that are called, get a new sheet of paper, a couple more things. Whoops, I didn't mean to do that, sorry. Okay, let's make this bigger. Boom, no. We're being very uncooperative here. There we go. Okay, so we also have oblique prisms, okay? There's, and you work with those the same way. This is a right prism, oblique prism. So maybe I can have, they like to trick you on these as well, because those math people are kind of mean, and they like to try to trick kids all the time. Okay, so this is oblique, meaning it's pushed over. So I could have a prism that looks like this, where all the sides are perpendicular. I could have one that's pushed over, but it turns out they have exactly the same volume if the bases and the heights are the same. So again, maybe in this case, they'll tell you that this is like, maybe they'll say that this side is 10 over here. And then they'll say, they'll like to do a tricky one, like they'll go like this, and they'll say that this is the perpendicular distance. And maybe they'll even do something really evil, like they'll tell you that this is 8 over here, and then they'll tell you that this side is 4 units long, and they'll say find the volume of this oblique prism. Well, the first thing that you got to do is find the height of the prism, and so if this is 8 from here to here, and this is 10, and this makes a right triangle. I probably didn't draw that exactly correctly, like that. Okay, if that is, if this side is perpendicular to there, and this is, let's call this 6, I'm sorry, and then I want to find this side over here, which is your height, you would have to do the Pythagorean theorem. So you go 6 squared plus h squared equals 10 squared. And so in this case, the height would be 8. Believe me on that one. It is. 36 plus 64 makes 100. And maybe this is a square-based oblique prism. So you could have a square-based oblique prism pushed over to the side with a height of 8. So the volume of this thing is equal to 16, which is the area of the base. What is that squiggle there? Oh, that's supposed to be a 4. Okay, is 16, which is the area of the base, times the height, which I found over here, which is 8, and 16 times 8 is 32, 64, 128, right? 128 inches cubed. Okay? So that's about as tricky as they get. They might get a little bit trickier, but you are smart kids, so you should be able to figure it out. Your homework on this assignment is page 517. Is page 517, 1 through 7, and 8 through 18 evens. Okay. And the end. This is Mr. Leader saying goodbye. See you soon.